Hello and a very warm welcome to GCSE Physics Chapter 2. Change of topic, we're looking now at electricity, static electricity to be certain. So when some materials are rubbed together, electrons can be transferred from one material to the other, and you recall from your lessons that electrons possess a negative charge. So therefore, a build-up of electrons will create a negative charge, and conversely a lack of electrons creates a positive charge. Now remember that two objects that have opposite charges will attract each other, and also objects having the same charge will repel. Now what many students do forget though is that both positive and negative charged objects will attract and be attracted to objects with no charge, neutral objects. It's why when you rub a balloon and induce a static charge, it sticks to a neutral wall. A charged object next to a neutral one will repel or attract electrons in that object, depending on the charge of the first object. This in turn creates an opposite charge on the surface of the neutral object, which then means that the two objects attract each other. They have opposite charges. Quick word now about conductors and insulators. Now, insulated materials can be charged by the transfer of electrons. If an object is connected to the ground by a conducting material, then the charge flows away. In the case of a conductor, a charge, electrons, can pass through. Now, whereas with an insulator, charge cannot pass through. Now, we've all probably experienced directly the effects of static electricity. If enough charge builds up, a spark may jump across the gap between a body, you, and the earth, or an earthed conductor, say a door handle. Now, aircraft fuel causes static as the fuel rubs against the pipe as it's being fueled into the aircraft, and a spark could ignite the fuel vapour, and the aircraft and the tanker are earthed to avoid the charge building up. Lorries, similarly, with inflammable gases and liquids, are earthed before unloading. And lightning in the sky, that happens when charge builds up within clouds, and this may be caused by ice particles rubbing against the air. When the charge is large enough, it leaps to another part of the cloud or to the ground. So static can be a nuisance. Some situations do not involve enough charge to be dangerous, but they can be just a nuisance. Dirt and dust are attracted to television screens, monitors and plastic. Synthetic clothing can cling to you. Cars are sometimes earthed to avoid shocks from car doors. It's caused by friction between you and the car. After walking across a floor covered with insulating material, you may experience a shock if you touch water pipes or some other earthed conductor. To prevent static electricity, we can do a number of things. Some ways to prevent static shocks include the following four: correct earthing, insulating mats, wearing rubber-soled shoes, and using anti-static sprays. But static electricity can be useful, and in the exam you may very well be asked to provide some of the uses of static electricity and provide a brief explanation as to how they work. Now remember, it will involve charges and attraction or repulsion in some way. You should familiarise yourself with these. Now, 6 common uses that you should really be aware of and confident about writing are 1. Photocopiers and laser printers. Now they use static to direct ink. Dust can be removed from chimneys by being attracted to a charged plate. That's your second one. Large particles form, falling when they're heavy enough or are shaken. 3. Fingerprinting. Now fingerprinting uses static electricity. 4. Some household dusters are designed to attract dust by static electricity. 5. Doctors use static electricity when treating heart attacks. 6. In paint spraying, paint is charged so that the droplets repel each other, giving a fine, even spray. A surface is given an opposite charge to attract the paint, ensuring an even coat and, of course, less waste. So in summary then, a build-up of electrons creates a negative charge. A lack of electrons creates a positive charge. A conductor allows charge to pass through it. An insulator prevents charge from passing through it. Static shocks can be prevented by ensuring that the charge doesn't earth through a person, for example by wearing rubber-soled shoes. So really that's static electricity. Now next time we'll be discovering what happens when the electricity starts to move. That's when it becomes really useful to us. In the meantime, if you haven't already, make sure you subscribe to our channel and click the bell to receive alerts when we've uploaded more videos. And don't forget to look for us on Instagram. If you have any comments, feedback, requests, or just want to let us know who you are or the fact you're there, then leave a message in the comments below. Until then, keep wondering about the universe.